Alrighty, welcome back to Michelle's version of calculus. It makes sense sometimes. 3.3 differentiating inverse functions. Alright, so the basic bare bones definition of the derivative of an inverse function is, of course, seen right here. Derivative of an inverse function equals, oh, don't know why my brackets are like this. Let me go ahead and just fix that real quick. Derivative of an inverse function equals 1 over f prime of the inverse, or like the derivative of the inverse, basically. All right, so three ways to the same things we can see down here. And this one's for inverse function. If g of x is inverse of f of x, or g of x equals f to the negative 1 of x. Remember, f to the negative 1 of x is another way of saying inverse. Don't confuse that with x to the negative 1, because that's saying two different things. That's saying 1 over x. And this over here is referring to an inverse. And of course, f of g of x equals x, because remember how we used to do, we used to use fog for composite functions to see if they were inverses of each other's, and they would have to both equal x. So anyways, that's the same thing for all of them, to all say basically they're inverses of each other. Alrighty, so we're going to go ahead and get into this example. The best way to do this is to do this visually, because it's just so much easier for you to see. So we're going to go ahead and draw out two tables, all right? You can use, we'll have x on this side, f of x here, and f prime x, which of course we know stands for the derivative, and this is slope. That's the slope. So then we have x. You can use g of x and g prime x. Alrighty. Alright, so of course our question here, it says at f of x, or at f of 6 equals negative 2, f of negative 3 equals 7, f prime 6 equals negative 1, and f prime of negative 3 equals 3. Find g prime 7. So that might have been a little confusing, but let's take it one little chunk at a time. So we have f of 6 equals negative 2. So we're going to be plugging in a 6 right here. Let's use purple. We're going to be plugging in a 6 right here. And we know that 12 value specifically equals negative 2. F of negative 3, the negative 3 we know equals 7. Alrighty. And f prime of 6 equals negative 1. And then f prime of negative 3 equals 3. Alright. So remember how with the inverses, you would basically plug in, with inverses, you basically would switch it, the x's and y values, when you'd solve for an equation. That is the exact same thing, but with the table. So you would literally just switch over these values of x's and y's, and that's how you get your inverse table. So that'd be negative 2. Oh yeah, let me just write inverse right here above it. This is like the OG in purple, inverses in red. So we'd have negative 2, 6 here. We'd have 7, negative 3. And of course, according to our previous definition above, the inverse, or the g prime x derivative, or inverse, whatever it's called, is literally just going to be 1 over negative 1. And it would be 1 over 3, according to our little definition up there. And of course, if you'd want to get from g of x to f of x, you would basically, remove it from its reciprocal. Like, just take it out of its reciprocal to get the f prime x there. Yep, and the question was asking find g prime. This is what the question actually wanted. Find g prime of 7, and we can see right here that g prime of 7 is 1/3. Alrighty, and that is all for differentiating inverse functions.